for Daniel. He's apparently driving right now. And then we will then we'll talk about how we want to do the final. So boom. Sharing whiteboard. So did everyone get number 1 right, or should we do number 1?
Nah.
I didn't get it right.
Oh.
Eli, did you set it up like this?
Yeah.
So somebody tell me what's backwards from that.
4t
cubed,
cubed.
8t squared.
Beautiful. Eli, you feel good. And then 0 to 5. Then you just got to plug in 5. 5 cubed is 125. And 5 squared is 25. I'm pretty sure that's 500. I'm pretty sure that's 200.
Yeah, I think so.
How did I get it wrong?
Well, 300.
I put them like I don't know. I had it all set up.
Mental math wins again. Dun, 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 dun. All right, number 2. Most of you guys did not fall for the classic error, but some of you did, which is okay. So this one looked like this. The most classic error is that people say that this area is when it stopped. But this is a velocity graph. So the only spot where it stopped is actually right there. So for part A, and if people put it wasn't stopped at all, I actually took it because it's just kind of almost like turning around right there. It stopped at 2. So where is this thing moving to the left?
0 to 2.
Maybe 2 to 5.
Oh.
Yeah. So yeah, left is 2 to 5. And then right is 0 to 2. So basically remember this thing, it's basically like this thing's moving like positive 2 feet per second, then it's slowing down, it's moving 1 feet per second, but all of this is to the right. And then right here is where it kind of turns around. And then it starts moving the other way, faster and faster, and then it just kind of goes the other way at a steady speed, right? So that very ending spot there is just where it's going the other way at a steady speed. It's not stopped, right, so to speak. Okay. So now this is where some people did B and C in more complicated ways than others. And if you did it right, the complicated way will work. But here's the easiest way, in my opinion, to do this. Isn't this total distance, right, everybody?
Mm-hmm.
So total distance is where we got to find the areas and make it all positive. If you took the integral from 0 to 2 of negative x plus 2, and you did this right, it would be this area. But I'm actually going to tell you, I actually didn't use the integral. I just used the area of the triangle. And I got 2. Is that okay for everybody?
Yeah. I was doing it by areas, and I just like somehow miscounted and had that triangle as side length of 3, and it just didn't work out too well. But you know,
I did something like that too.
And
like
so
I had the other one below the axis and everything. I just like couldn't count.
Oh, I got you. Yeah, I didn't look at it close enough to figure out what was going on there. But then technically, some people actually set up integrals for the second one as well. They said the area from like 2 to 3 of negative x plus 2, because that's the same line, and then the area from 3 to 5 of like negative 1. And if you found all those integrals, like this would actually be negative 1/2, but you make it positive, and this area would actually be negative 2, and you make it positive, and you add all those together, you get the right answer. But again, I just found areas, and I was like, oh, the area of that is negative 2.5, but we're going to turn it positive. Is that okay for everybody? So your final answer for part B is 4.5. Is that cool for everybody?
What?
Yeah.
Yeah.
I just got really confused. I don't know. I think I just forgot everything.
Yeah, so just remember that total distance is like total area. It's just finding the areas and making them all positive.
So on my quiz rework email, you put 2C, 4 plus 2, but negative 2.5. Were you meaning that for B, or is that for C?
No, so yeah, let's talk about C here in a second. So yeah, for B, that's
well, because I got B wrong then too, but you didn't mark it.
Oh, sorry. Okay, yeah, fix B. Eli, what was your question?
I don't know. I'll figure it out.
Our refrigerator's here.
I thought it was distance. I thought I had to do a distance formula.
Oh, no. Yeah, no distance.
And then I tried to do that, and then I erased it, and then I was like, this isn't right, so I just didn't do it.
Yeah, no distance formula.
Okay.
Yep, just areas there. And then C has to do with distances as well, but there's two things you got to keep in mind. It wants to know where it ends up, which means instead of doing total distance, for C, you're actually doing displacement, because you don't want to know how far it traveled. You just want to know how far away it is from its starting point, or like where it ends, or et cetera, whatever they're asking for. So displacement is where you actually use the 2 from part B and you use the 2.5 from part B, but now the 2.5 is negative because we're not making them positive anymore if we're doing displacement. So then when we add those together, don't you get negative 0.5? That right there is the displacement. But instead of, they didn't actually want the displacement, they just wanted, where does the particle end up? Well, that's where you take its original, which is 4, and you add negative 0.5 to it. So what's 4 plus negative 4? Negative 0.5.
4.5.
So we got to
3.5.
Yeah. Boom. So that's your final answer to part C.
I got C wrong for the same mistake as in part B. Do you want me to fix C? Like, you didn't mark it. So do you want me to fix it, or?
Fix it, but you don't have to put your mistake for that one because it's the same.
Okay.
Yeah.
Wait, where did the 3.5 come from?
So we took the negative 0.5, which is the displacement, and we added it to the original position that they gave us at the very top, which was S of 0 equals 4. Yeah. Friends, you don't even know how many emails I am doing today to tell parents how to turn in stuff. It is ridiculous. Like, I'm gonna be so happy when this week is over. Anyway.
So you guys have to make like all new packets for the rest of May, or rest of our school.
Thankfully, the math ones are split up, so I only have to do the Algebra 2 one, and it's kind of stat-ish, so stat can use it too, but like, it's a pain in the butt. It's the worst. And I hate stat. You guys might not know that about me, but if there's one area of math that I don't like, and it's statistics. Like, I just don't enjoy it at all. And so now I'm like, you've taken the fun part of teaching away from me, which is seeing students. And now you're making me do my least favorite area of math. And do all the things I hate about teaching. Like, it's just, like, I cannot, it's due in like 2 days, or on Monday morning, it's due to Mrs. Ferris, so she can make copies of it. And I don't have hardly any of it done because I'm so unmotivated. So if you guys are feeling unmotivated, I feel that. It's so hard right now. I feel it. Number 3 was pretty good.
Yeah, this one confused me. Like, I thought I did it right, and I checked myself on Nint, and I got it, and it was fine, but I didn't get it right.
What was your guys' bounds?
-1 to 2.
Yes, because it's a y integration on this one as well, right? Because it's terms of x by itself, so we have the equations with y in them. And so it's -1 to 2, good. And then it's negative y cubed plus 2y plus 4. And then you got to subtract out the y squared minus 2y. Is that okay? So is that the setup that you had, Emma?
Yeah.
All right, then so if you distribute the negative sign, sometimes that gets people too, then we're going to combine these. And then we're going to go backwards from negative y cubed minus y squared plus 4y plus 4.
Yeah, that's what I had too.
So weird. Well, we'll just keep going. Keep on, keep on. All right. So negative 1/4 y to the 4th minus 1/3 y cubed. I don't know if anyone's done this, and Emma, I'm not saying this is your mistake, but I did go to do one last night where this was just the worst. I pressed into Nint like what I haven't read, but like that means I have backwards, and so like that would have been going backwards twice. And I was like, no wonder I'm not getting the right thing to double check myself. Okay, I'm going to rewrite this on the next page so we can do all that work. So -1/4 y to the 4th minus 1/3 y cubed. What is it? Plus 2y squared plus 4y? Was that what it was?
Yep.
Mm-hmm.
Cool. All right, if I plug in 2 to the 4th is 16 times a -1/4 is -4. 2 squared, oh, this should be cubed. My bad. 2 cubed is 8 times the -3rd is -8/3. 2 squared is 4 times 2 is 8, and 4 times 2 is 8. So that's the first one. And then subtract out whatever you want to plug in -1. -1 to the 4th is 1, so that's -1/4. -1 cubed is -1 times -3rd is plus 1/3. -1 squared is 1 times 2 is 2, and then -1 times 4 is -4. So now I am going to do 8
so far,
plus
so
8.
good.
This is so weird. 8 plus 8 is 16. Minus 4 is 12. So 12 minus 8/3. And then I'll combine these and make that a -2, but then I'll distribute this to everything. So plus 1/4 minus 1/3 plus 2. So this is 14, but then this is minus 9/3, which is just 3 plus 1/4. So that's 11 plus 1/4, so 11 1/4.
That's what I had.
I marked it wrong?
Yeah. But maybe it was because I got 2C wrong. And you like, I don't know.
Look at email. Yeah. Oh, I said only things you missed are 2B and C.
Oh, okay. I just can't read now. That's great. My bad. All right. Well, I'll work on 2C then.
There you go. Yeah.
Yeah, I was so confused. I was like, I even inted it and it was right.
Yeah, no, you got that one right. You good? Everybody else good on number 3 then?
Mm-hmm.
Sweet. Number 4, shout out to Sarah Brandon for like the neatest graph ever. It's quite nice. But did you guys get, it's nice that they gave you the setup. Did you guys get the setup was they give you the bounds and did you put cosine on top and minus sine 2x was on the bottom?
Yeah.
Yes.
So if you didn't have that, you just have to check out your graph, but it was nice enough that they gave you where it met. So this is one of those where mint is really nice because your final answer is 2.25. And if you mint it, you find that out. But we can do it like it's like we said, we're double checking it by hand. We can do this by hand. So backwards from cosine is just regular sine, right?
Mm-hmm.
And then backwards from, what's backwards from negative sine 2x?
Negative, or no, positive 1/2 cosine, or 1/2 cosine 2x.
Yeah, nice. Because that would go negative when we take the derivative. We got 1/2. So then we go from pi over 6 to negative pi over 2. And this is not as bad as you think, because sine of pi over 6, like they make these actually really nice, because I'm pretty sure that's a half. And then this is no longer cosine. When you plug a pi over 6 in right here, it's 2 pi over 6, but that's pi over 3. And then that's actually also a half, like cosine of pi over 3 is a half, and a half times a half is a fourth. So that's what you get when you plug pi over 6 in. When you plug negative pi over 2 in, sine of negative pi over 2, I'm pretty sure is -1. That's negative. And then when you plug that in right here, that just turns into pi, well, negative pi, but negative pi, -180 and positive 180 are the same thing. And cosine of pi is -1. So -1 times a half is -1/2. And so then you just distribute this and you've got a half plus a fourth plus 1 plus a half. And that's 1, 2, and a fourth. How's it going?
Wait, but if you plug in the negative pi over 2 to the x on cosine, wouldn't it be negative pi? And then wouldn't it be 1?
Good question, but negative pi is still negative 180, but negative 180 and 180 are the same spot. So it's negative 1.
Oh.
Yeah, because it's the left side of the unit circle. Yeah, good question. All right, let's see on number 5. My guess is between you guys, you'll be able to find your mistakes and put them together here. Number 5 is you are supposed to draw this thing and this thing, and oh, those were really bad on the axis, my bad. You guys get the idea. But you guys probably know and figured out that this meets at 2, 4 and negative 2, 4. Now here's the thing though. You're revolving around the y-axis, and as soon as you're revolving around the y-axis, you know you're using y integration. So what does that mean about our integral?
From 0 to 4.
Yeah, we got to look at it sideways. So it's going to go from 0 to 4. So that was one. Some people, if I said, hey, use y bounds, that was you. Some people went from negative 2 to 2. The other thing, though, is you actually can't use x squared. Because if we're doing y integration, what do we have to get by itself?
Y.
X.
Or x.
Yeah, it's already by itself. So we got to square root both sides to get x equals root y. So that's actually also what we have to use. So I saw a ton of people have the pi r squared right and looking good, but basically there was only a few people who actually put their bounds and their radius in terms of y. I had some people who did the root y part right, but did negative 2 to 2, and I had some people who did the 0 to 4 part right, but still use x squared. So you basically had to be right there. And then this one's actually super, super easy to go backwards from, because if I pull the pi out, it's literally just y dy. Right, so it's 1/2 y squared from 0 to 4, and 0 is going to be 0. 4 squared is 16, divided by 2 is 8, so it's 8 pi, which is about 25.13 or something like that. You guys
I used x value for the bounds, and I got so confused when everything canceled out.
You're like, wait a second.
This definitely has volume.
Right? Why does it have volume? Because you still use the root y, right?
Yeah, I did.
Yeah. Because if you use the x squared, then you'll get a lot of volume because it'll be going around the x-axis, but that's so funny. And then 6 was obviously the big one. I think only one person got it right. Maybe 2 people did. I can't remember.
Got it right.
So maybe there was a couple. Maybe
I
there's
did
3.
not.
Daniel got it right, I think.
That wasn't me trying to brag.
No, you're good. Daniel got it right. I think Chloe, you got it right. And I think maybe
I got it.
Emma got it right? Oh, well, good.
If I can read the email properly.
Oh, that's true. Because you only missed 2 B and C. So that means we're up to I like it when there's a 4th of us or so who get the hard question right. So we actually, believe it or not, did this question, but not with volume, with area, like on a homework or something. So there's this, and then there's this line. Now here's the thing. They say bounded by this axis, though. So really what's interesting is you're not actually using this part of the line. Like, I mean, you know that is the line, but you're actually only using this part of the line, which is really helpful to know. Like, this is the line y equals x minus 2, but you're not revolving that part of it. So I'm just going to get rid of it. And then this is the line or the curve y equals root x. And then we are using the axis. Now this thing is going to go around the x-axis. So we know we're using x integration. Okay, so it's going to go this way. But does everybody see why the hint makes sense? Do you guys see why there's actually going to be 2 different things you have to do?
Mm-hmm.
This thing right here, this part of it, has no hole in the middle. But this thing right here, the second half of it, this has a hole in the middle, right? So does everybody see how, like, the second part of it, like this first part of it, is just going to be the pi r squared method? But the second part of it is going to be the pi r squared minus pi r squared method. That's why you got to split it into 2. Does that make sense to everybody?
Mm-hmm.
Yeah.
Sweet. So for the first part, what are the bounds on the first part?
0 to 2.
Good, 0 to 2. And then it's just pi r squared. And it's just one equation. What equation is the radius here?
Square root x.
Yeah. So I'm just going to finish this part really quick because this is the exact same as the above problem, except for we're only from 0 to 2 instead of from 4, which does not cut us in half. Parabolas don't work symmetrically, but 1/2 x squared from 0 to 2, and 2 squared is 4, divided by 2 is 2. So this part's just 2 pi. Everybody okay with that? Yeah. So we got the first part. Now the second part. The bounds are from 2 to 4, right? So we're going out to here. What's the first radius? What's the big radius?
Square root x.
Square root of x.
Yeah, still square root x again, so that's nice. And then what's the second radius?
X minus 2.
Nice. And this is where nint is just more nice, I think, because you pull the pi out. You're going from 0 to 4, and then root x squared is x, but you got to FOIL this. So that's x squared minus 4x plus 4. And then you got to distribute the negative to everything. So it'd be negative x squared plus 4x minus 4. And then you could combine these. So I'm going to go ahead and put my work up here. Sorry about that, but that's the only spot I got room. So it'd be negative x squared plus 5x minus 4. And then you're going to have to go backwards. Negative 1/3 x cubed plus 5 over 2 x squared minus 4x. So this is definitely one where it'd be nicer to have nint, for sure. Because we don't even have a 0 to plug in. And we're going to take it times pi at the end, but I'll figure that out at the end. And we're going to have to add it to the 2 pi. So we'll keep doing work up here. Ew, 4 cubed is 64, so negative 64 thirds. 4 squared is 16. 16 divided by 2 is 8 though, plus 5 is 40. Plus 40, minus 16. So that's what you get when you plug in 4. Subtract what you get when you plug in 2. 2 cubed is 8, so negative 8 thirds. 2 squared is 4, times 5 is 20, divided by 2 is 10. Is that right? Yeah, 4 divided by, yeah, minus 8. Boom. So I'm going to distribute that negative. So I'm going to have negative 64 thirds plus 8 thirds, so those will go together for us. And then 40 minus 16 is 24. 10 minus 8 is 2, and it's minus 2. So it'll be plus 22. I'm running out of room here. Negative 56 thirds plus 22. Well, you know what I'm going to do? I'm just going to get a common denominator because that's 66 thirds. So it'd be 10 thirds. 10 thirds pi. And then if I add those together, I can do that by getting a common denominator because that's 6 thirds. So 16 thirds pi is your final answer, or it was about 16.75.
We just have to write down what we did wrong, right? Since we're on the Zoom call.
Yeah, just write down all your right work, but then write down what you did wrong. You don't have to put who helped you or right, whatever.
Wait, is that the same as 10 2/3 pi? Which is what I had.
No. That's weird. You know what I think? You know what I think I did, Emma? Maybe double check some work there, because I think I saw your 10 2/3 pi and thought it was the 10 thirds and the 2. Do you have the same setup? The setup is what I'm about to circle in yellow. So the setup is this for the first part and this for the second part.
Yeah, that's what I had.
Okay, so it must have just been a math error somewhere then. Because it'd be 5 and Well, actually, you've just doubled something because it should be 5 1/3 pi. Yeah. All right, I'm gonna stop recording here.
This is
Yeah, I'm
bittersweet.
not sure.